show of hands, who considers themselves, or first actually to start off, who here is an Android developer? Or has some familiarity with Android? Doesn't have to be a lot. All right. And then just out of curiosity, who considers themselves comfortable writing tests? And who has tests alongside with your production apps? And who is satisfied with the number of tests that they have for their apps? Just so you all know, this, as it says in the title, this will mainly be focused around Android tests, but I hope that you can take at least some takeaways away, no matter where you're writing code. So to start with, why should you test? Testing your code can take more time up front, but there's many benefits that come later on. For example, you can change or refactor your code with confidence. Often, when you're changing or refactoring your code, things can break. You try your best to catch all of the cases and all of the bugs that might happen, but there's often something that you forget to click through. By automating these tests, you can be more confident that your changes didn't break anything. Not to mention the time that you'll save from needing to manually click test all of the things. Tests can also be a form of living documentation. In order to understand how a part of the code works, if there's well-written tests, you can just pop over to the tests that describe what the code is supposed to do, what the expected behavior is. And then you can spend more time writing the code than figuring out what the code does. Writing tests also encourages maintainable code. If you're actively writing tests, you want your code to be architected in a way that's easy to test. And the same patterns often follow patterns of single responsibility that gives you cleaner, easier to maintain code. And writing tests for Android can be hard to learn. Many of us feel lost when it comes to testing. There's so many libraries whose APIs you need to learn and make sure work well together. You can get unclear errors and not know where to go. The issue might be that libraries don't play well together, or there's just something that you're missing. It takes your focus away from what you're trying to actually do. Write tests and write code. With so many factors, it's hard to get comfortable writing tests and making testing a habit. This overhead is just part of why it can be so hard to get tests written for your app. Half of the people who responded to this poll don't have any Android tests with their app. When you're feeling lost and not seeing the benefit of the time that you're putting in writing tests, it can be hard to be motivated to keep up with test writing. Sure, there's sometimes time constraints, such as from clients, but so much struggle is from how hard it can be to write tests and how long they can take to build and run. And when it's hard enough to solve the problem of creating tests yourself, it's even harder to get an entire team on board with all of these challenges. And when your entire team isn't on board, it's really hard to keep your test suite up to date. You'll always be trying to play catch up, writing tests for your own code and other codes, or just letting it fall away. The best way to solve this is to work on removing the hurdles for getting started testing so that others have an easier time coming on board. Because no matter how much we try to architect away from it, there will always be some part of our code that interacts with the Android framework. There's a 70-20-10 split guideline that creates a period where 70% of your tests are unit tests, 20% are integration tests, and 10% are UI or end-to-end tests. This means that 30% of your tests are integration or end-to-end tests. These Android tests can be some of the hardest to write and take the longest to run. But it's still code we should test. Writing small and fast unit tests is probably the quickest and easiest way to verify the code that we write. But if we build a feature or a screen, we need to verify how all these pieces fit together and interact with the Android framework. These are the kinds of tests that this talk will focus on. I'll focus more on integration and UI tests rather than unit tests. And today I'm going to talk about one category of options for testing in particular, and that is AndroidX test. Before I dive in too much, just a little bit about who this is up here speaking to you. As was mentioned, I'm an engineer at Buffer. Our apps make it easy to schedule posts for social media, track performance, and manage accounts. We are also a fully remote company, so feel free to ask me about working remotely or about the company itself. I'm also an author and editor at rearwindolit.com. I'm on their Kotlin and Android teams helping making learning materials on those topics. I'm a happy hedgehog and cat owner, and I love putting photos of them on my slides. I do have these slides online that I will share the link at the end of the talk for you to access. All right, so there are so many tools at our disposal to try to make testing easier. Just on Android, there's JUnit, Retrofit Mock, Espresso, Mockito, Electric Spec, Kotlin Test, Mock-K, It's so many others, more than what's listed on here too. How many of you use at least one of these tools? All right. These tools live to make testing easier, but it means you need to remember all of these tools. Pick between them, remember how they work together, what their APIs look like, which one can be run on the JVM, which ones need to be run on a device, and so on. Google is trying to help solve this with AndroidX test, which they announced at the last Google I/O. This is a set of testing tools that are a part of Jetpack. It includes some of the libraries you might already know if you're familiar with testing on Android, such as Espresso. With it, the goal is that there's less thinking about which library should I use and more test writing. Also, there should be less thinking about where to run your tests. When using AndroidX test, you can run tests on a physical Android device or locally on your machine, which is not possible with all other libraries. And all this is without really needing to do much anything else extra. You can run the same test anywhere that you want. Some other things that could matter to you: it is also open source, so feel free to go take a look at it directly. And then Google is also updating the documentation to use this, so it is going to be the standard according to Google for what to test with on Android. So what's included in the AndroidX test? What are we looking at today? Google describes AndroidX test to have 4 distinct sections for different testing needs, and we'll cover each one in this talk. There's the JUnit 4 support with the runners and rules you might already know if you're familiar with testing on Android. It also allows you to get the application context in your tests in a new and easier way. You can think of this section as maybe the scaffolding to build your tests on. And then there's core. This has a bunch of new stuff. Much of it has to do with handling activities, fragments. This is where you set up the situation or scenario that you're testing, often called the given section, such as given valid credentials. This has some of the exciting bits, in my opinion, and we'll look at them a bit more in detail in a few minutes. Then there's espresso for your when case. For example, when this button is pressed. And it has everything that you need for UI testing. This is the same espresso you already know of if you're familiar with testing on Android, just brought under the AndroidX namespace. And then there's Truth. This one has more new stuff. It has some nice matchers for Android objects, making your tests easier to read and your error messages more understandable, as well as making your tests a little bit easier to write. We'll learn about some of these features by walking through writing a couple tests for this app. This app is called Task List, and it's used to break down tasks into smaller things to be done. Sometimes tasks can be overwhelming until you break them down, such as learning about testing on Android. We'll look at each of these 4 sections I just described: JUnit, Core, Espresso, and Truth. So with that, let's get started creating a new test. The first step is JUnit. Remember that the JUnit section is the JUnit 4 support with the runner and rules you already know if you're familiar with testing on Android. It also allows you to get the application context in your tests, and you can think of this section as your scaffolding. There are 2 dependencies that you need to add to get started with this. The first is just plain JUnit 4. This one's not a part of AndroidX test, but it's what AndroidX is meant to work with. And then there's the AndroidX test library that uses JUnit. You also need to make sure you specify the test instrumentation runner in the default config block of your Gradle file. This, as well as some of the other dependencies I'll show, are usually all included when you generate a new Android project. But in case you're working with an existing project or they're not there for some other reason, I'm including them anyway. Notice also that I'm using test implementation instead of Android test implementation, if you're familiar with the way dependencies work for testing. This is to show that you can run these tests off device, and if I wanted to run them on device, I would use Android test implementation. So here we go, setting up the test class for the main activity. This tells JUnit to run the test inside of Android JUnit 4 instead of the runner built into JUnit. Android JUnit 4 is a test runner that runs JUnit-style tests for Android tests. And when used in Espresso tests, it helps control the launching of the app and running those UI tests. So the run with annotation is part of just a standard JUnit, and that's what we pass the Android JUnit 4 to. Android JUnit 4 is from the JUnit part of AndroidX test. You can use this runner instead of Roboelectric test runner when running Android tests locally on your machine. This section also includes a new way to access the Android context. Previously, you could get both the app under text context and the instrumentation context from the instrumentation registry. And it wasn't clear by naming which was which and which you might want. There was both get context and get target context. By using application provider get target context, it's clear which app context you're getting. And this is generally the one that you want. It's easier to think about this way, not needing to remember if get context or get target context is the one that you want. And with what you have scaffolded already, you're set to run tests on a device, but you have one more step to run your tests off device on your machine. And that's add the Roboelectric dependency. It's starting with Roboelectric 4.0 that you can run all of these tests off device. So make sure you're using version 4.0 or higher. And then one last thing is to make sure your test options are set up to include Android resources in your unit tests.
Are you taking questions during the meeting?
After, if you don't mind. With that, we'll move on to the second part of AndroidX test, which is core. And this is the one that has a lot of the new stuff. Remember, much of it has to do with handling activities and fragments. This is where you set up the situation or scenario that you're testing, often called the given section, such as given a successful login. And this has some really exciting parts in it, I think. It also has some great builders for Android objects. We don't need to add any more dependencies at this point. It's all included in the dependencies that we've already added. So here we go, writing the test, the first test for this app. It's a basic launch test just to make sure that the main activity launches without crashing. Normally, I don't find value in adding this test if I have other tests as well, because the other UI tests won't pass if this one didn't. But for a simple example to start with, and if it's the only test that you can add, that's when it's valuable. So what we have here is a function with the test annotation that's a part of JUnit. And then we have the fun stuff inside. The new activity scenario is used to launch the main activity. You call activity scenario.launch with the activity class name to do this. This is cool. You can use this instead of the activity test rule that you might know. This creates the activity and brings it to the resumed state where it's visible to the user and ready for input. Because it can be used on or off device, you don't need to remember if you need activity test rule or roboelectric setup activity or roboelectric build activity for on versus off device tests. You can just use this one scenario. And the scenario handles more than just the launching of your activity, but it also handles some synchronization with the system and provides support for lots of things such as scenarios around your activity's lifecycle. To start playing with this, when you launch the activity, you can keep a reference to the scenario. You can then test the way that your app behaves under certain lifecycle events with the scenario by using a move to state call. You can step through the lifecycle events, verifying your behavior. The framework will keep you from stepping through in an invalid way, eliminating the cognitive load there. For example, it won't let you move on after you've destroyed the activity. If you do want to test how your activity behaves after the system destroys the activity and then recreates it, you can use the recreate method. With it, the current activity will be destroyed after its data is saved with onSave instance state, and then it creates a new activity with the saved state. After this method call, the activity state goes back to the same state as the previous state. And I think this sounds like a way that you can test how your activity would behave with a configuration change, but I have not verified this. And then one last thing here. You can use close to free all the resources and bring your test back to their initial state. It's recommended that you use this if you're not using the scenario rule to avoid flaky tests, which will take care of this for you, which, speaking of, there's an activity scenario rule that you can use instead of using activity scenario to launch your activity manually in each test. You can use this instead of activity test rule that you might be familiar with. A test rule is a tool to change the way tests run, sometimes adding additional checks or running code before and after your tests. In this case, It handles launching your activity before your test, and closing everything and freeing up the resources and bringing their test back to their initial state after your test. So the same thing that happens when you use activity scenario.launch, the beginning, and then close. Then you can access the activity scenario directly from the rule and use it the same way that you did in all the other cases, just by using the scenario property on the rule. This next part of the core stuff does require another dependency to add. As you might be able to tell from the name, fragment testing, this one deals with fragments. And it's a fragment scenario, similar to the activity scenario, but for testing fragments in isolation. No more do you need to build a solution yourself or set up the entire surrounding activity or maybe use yet another library. You can use this. And it has the same control over lifecycle events that you get with the activity scenario. When using this, you do need to make sure you build your fragment in a way that's independent of a specific activity. But you should probably be doing that anyway if you're following recommended practices. And one more part of core includes builders for Android objects that might be hard to create otherwise. Whether they have private constructors or whatnot, this includes builders for application info, package info, motion event pointer coordinates, and motion event pointer properties. They follow the same pattern of the name of the class with the postfix builder. So here, package info builder and application info builder. You can chain together using the builder pattern and then build. And this is used for some Android classes that might not have public constructors for you to create in your tests otherwise. All right, now the third part of AndroidX test is espresso. This is for your when case. For example, when this button is pressed. And it has what you need for any UI testing, setup and verification. It's the same espresso you might already know if you're familiar with Android testing, just brought under the AndroidX namespace. It handles some of the multi-threading and synchronization for you. It tries to have a readable API for interacting and testing your UI. It has all the assertions and matchers for your view. Again, without needing to run it on a device, you can run it on device or off device. To get these main parts of espresso, you need to include the espresso core dependency. Again, here I'm using test implementation to run them off device, but if you want to run them on device, you would use Android test implementation instead. So if you're not familiar with espresso, there are three main things to understand: view matchers, view actions, and view assertions. View matchers search to match a view that's on the screen, so you can perform actions or make assertions. The first one we'll use is to match by ID, which can be the most common, but you can also search by text, content description, so many others. You can even build your own. Then view actions are used to perform actions on views that were matched, such as a click. For example, once you use a view matcher to find a view with the ID floating action button, you can perform a click on it. Again, there's lots of actions that can be performed and gestures, and you can write your own as well. This step is optional to use, as some tests won't require performing any actions, but it's really helpful when you do need it. And then view assertions verify that something is true about the view that was matched. You can check if a view is visible or contains the text that you expect. Once again, there are many of these, and you can write your own. So here's a test that checks that the main activity is launched and it has a button add list. The main activity is launched using the activity scenario, and then we test for the add button that should be on the screen. With ID is that view matcher to find the button with the ID button add list. Then matches is our main view matcher, or view assertion. Is displayed is the view matcher we pass in. This checks that the view with the ID button add list is visible on the screen. Previously, you might have had to learn one API for Espresso to run UI test on device, and maybe another to run them off device. With this, you can use the single Espresso API to run them wherever. Espresso has a lot of other libraries as well to help you with other things such as maybe web views or accessibility checks. Two that we'll take a look at quick here is for intents and recycler views. And the recycler views part is a part of the Espresso contrib library. This is a test that when a list item is selected, the detail view is shown. There's a lot here, so I'll break it down. We start by using the activity scenario, just like before, to launch the main activity. Keep double clicking. Then the first library we added for intents is used. We init the intents to listen for intents that are launched. Now to use the recycler view matchers and actions that are a part of Espresso contrib. We use the recycler view matchers to click on the first task in a list, which is a view action. First by matching the recycler view by ID, then using the perform action at position 0 to click on that first item in the list. Note that the detail activity won't actually start at this point. When using intent matchers like this, it intercepts the intent so that we know that it was sent, but it doesn't actually open the activity. This is really handy if you want to know that opening that activity was triggered, but you don't want to set up everything that you might need to open that init test, such as maybe stubbing the network layer. And then back to using intents. We verify that intent was sent with the component detail activity. This is our verify. And then finally, you need to release the intents matcher anytime that you use it. I like using a custom DSL for this so that I never forget. All of this starts to show how you can use the different parts of the AndroidX test together seamlessly to build more complex tests to run both on device or locally. Now, truth is the fourth and last part of AndroidX test. This is an optional assertions library, and you don't need it to write tests, but it can make your tests more readable and error messages easier to understand, and possibly a little bit easier to write as well. So while it's not required the way that Espresso can be to write some tests, it can be very nice to have. And it's all about the verify step, sometimes called the then step of your test. The part that verifies that your test behaves as expected. AndroidX Truth is built upon the truth library from Guava. Guava's truth can be an alternative to JUnit or Hamcrest-based assertions. In general, you use truth to verify that an object has a specific property using code that reads almost like a sentence using the conditions that you're testing. for example, using the intent subject in the AndroidX truth. You might code using the sentence, assert that intent has no action. This is an example of how the AndroidX test extension of this library provides some cool matchers. So let's use some more by rewriting the test that we just wrote using truth for the assertion step. To get started, we do need to include the dependency for it. As you might expect, it follows a similar naming convention as the other AndroidX test dependencies. Most of this test is the same as the previous test, so let's just pick apart the assertion step. You first grab the first intent using getIntent, which returns a list of captured intents. This is apart from espresso intents. And then, this is the part that uses truth. You use the intent subject, assert that. This returns an instance of an intent subject for the intent that you're testing. Then you have an assertion on it. Here we're verifying that it has the component class detail activity. Reading it out, it says, assert that intent has component class detail activity. Other intent assertions include extras, actions, flags, type. There are also subjects for a lot of different things. So let's look at a few more. The detail activity in this app provides its own start intent with new intent. Here, we test that it has the bundle extras that we might expect. We'll break it down to make it easier to look at. But real quick first, for reference, here's that new intent method. It takes a task list and a context, and it creates an intent for the detail activity, putting that list ID as an extra. This calls the method on the detail activity to get the intent we want to perform our tests on. We'll be testing that this method builds the intent correctly. Notice that we're using the application provider that I mentioned earlier to get the application context to pass in as a parameter. By using assert that intent.extras, we're able to get a bundle subject to perform our verifications on. Here we're looking that it contains the key extra task list. Yes, this could be changed instead of assigning it to a variable, but it's written this way so that you can see the type explicitly. To keep building on that, we can use the key for that integer extra to get an integer subject. We can then use it to verify that value is equal to the task list ID as we expect. I mentioned how nice the error messages are, so let's take a look at a couple. This is one for if the component class is incorrectly main activity instead of detail activity. It clearly states that the value that was being tested, the intent class name, what was expected, detail activity, and what the actual result was, main activity. Compare this with the error message that you get if you're testing this without truth. I'm not going to walk through all of this, but know that it means the same thing as everything on the previous slide. Here's another one for the verification that there should be an extra task list, but there's a task name one instead. So we know we're testing the value of intent get extras. We expect it to contain key extra task list, but instead get extras returns a bundle with the task name laundry. And then one more. Even checking for integers can be more readable. Here, it says that we're testing the value of the extra task list. We expected it to be 4, but was 5. This is what it looks like when you're using the JUnit assert equals for integers. Sure, you still have the expected and the actual, but the error message doesn't include the information that the value that we were testing was intent get in extra task list. There are a lot of different subjects that AndroidX test adds with truth and include similar ways of using them and similar messages that we just saw. Here we just looked at intent subject, bundle subject, and integer subject. But there are subjects for all of these Android classes as well. So motion event, pointer coordinates, pointer properties, everything up there. All this is to say is that Google wrapped up all of their testing libraries under the AndroidX namespace, while also giving us a lot of great new things. These libraries are in 4 categories. JUnit, which has all your needs for scaffolding and accessing the Android context. Core for setting up your tests, launching activities, and building Android classes. Espresso for all your UI-related testing needs, and Truth for making your assertions a bit nicer. The testing APIs you might be familiar with are from before, all still available, but they may be under a different namespace or might no longer be the recommended pattern. The tests that we wrote in this talk, and any test using these libraries, can be run both on-device or off-device locally on your machine. All you need to do is drag them to the appropriate library, Android test, or just test. And if you don't have the dependency included for both test instrumentation and Android test implementation, you need to make sure the dependency is included for wherever you're running it. Now, hopefully, you can use some of these APIs across all layers of testing and worry less about what the API is or where you're going to test it, and more writing the tests themselves. Before we go, I do have to mention at least Project Nitrogen. I don't know too much about it yet, but I'm excited to learn more. It's a test executor meant to be a single entry point for all of your tests in any extra execution environment, from local to on-device to a CI. With it, you should be able to more easily move tests between different runtime environments, such as on-device or locally. It also gives you lots of data from your tests, like logcats, screenshots, battery performance. It was announced at the last I.O., and I'm hoping to learn a lot more at this upcoming Google I.O. And with that, I want to thank you all for coming. Up on the slides is a link to the resources, which includes a link to these slides. And with that, I want to open it up to discussion. With this size of a group, I like to have it more of a conversation without anyone just back and forth questions. I'm happy to answer any of the questions, but if anyone else wants to give input too, we're all smart people.
So I'm just running instrumentation tests, your Android test, and kind of seeing Espresso, key stuff in. What does it look like when you're running it as tests then?
It's basically headless, where you see the logs, but it's not on test. You don't have to have any test connected.
So the emulator device is not running that?
Nope, you don't need any device running it. It just runs just on your computer. You don't need an emulator or a device.
Would there be limitations to what you can test then at that point?
I think there are some, but not many, such as if you're interacting with hardware. I think there's limitations there. But for most just like screen things, and I think like some of our stuff that might have set up. I haven't tested the limitations of that. I've mostly done like studying out any network, mostly testing what's on screen. It's the same limitations you might have with some like the road electric stuff, but you can easily test them out that too. So you get most of everything that you get when using an on-device and an emulator, with maybe some restrictions around some hardware stuff. It's a bit faster running it locally, but you don't have to watch it flash on your screen. You can control your device.
That's the fun part.
Until you're like, I've watched this 50 times.
Do you have to worry about the properties of the Android being a later version versus an earlier version?
Not that I've come across.
Got another one. We're starting to run into a situation where we want to test kind of API calls. And so we're still trying to figure out the best way to do that. We've looked at a few mock API servers, like WireMock and that. I just wondered if you or anybody in the group has done anything there and what they might recommend in terms of, being able to have a more, a test that's, what do they call that, hermetic, or it's happens to get the same way, where if we test against the real API, sometimes it's slow, sometimes it's not. But we want a deterministic test, so WireMock can sort of specify, I guess, like if you want it to fail or if you want it to take 20 seconds or something. So I'm just curious if anybody's run into that and what they've done.
I know personally I've used mock web server, but most of the time we haven't needed to go that in-depth with our network layer. We just usually like stub the API calls. We use retrofit, so we'll just like stub the retrofit response using Mockito. But when I have had to go like more in-depth, we use mock web server where you can give it a JSON you want it to return for a call. And you can say if you want it to be slow or fail with a specific error message. So that's what I did in the past. I don't know if anyone else has other things that they've tried.
I've actually gone back and forth between using something like Mockito and PowerMock versus using something like WireMock. So what it really came down to was on a per project basis. So it depended on how embedded the API calls were into our existing infrastructure. So basically on something like an older code base, we had issues where things that made API calls weren't easy to abstract out and mock because they were very heavily embedded within the business logic itself. So in those cases, we would use something like WireMock. But in cases where we actually could stub out the entire classes and basically pretend that we were the repository, stuff like that, we use PowerMock and Mockito.
Thanks.
Right, well, I'm happy to continue having conversations after I put the microphone down. Feel free to come up. I also have stickers here. If you're just interested in stickers, you're going to come to say hi or a sticker too. It looks like we have CJ stickers on here too. Yeah.
By any chance, do you have an example?
For the test, for these ones, let's see how long Android Studio takes to open up. But also, I'm going to publish the project that all these examples are from this week. I'm also doing this talk on Friday, so I'll make sure they're posted to that link by Friday.